And welcome back. As we continue our discussion on arrays, we are now going to venture into a very important topic about arrays, which is that of sorting them. So when we're discussing sorting, one thing you have to understand, sorting arrays is a very standard algorithm development, and we use this a lot of times to sort data. Very common thing, sorting from smallest to largest, or in reverse, from largest to smallest. So what we're going to do is we're actually going to develop an algorithm to sort data in an array. Arrays are actually a type of data structure that we can use to not only hold data, but to use it in a meaningful way. So to start us off, we're going to define a method called sort that will sort an array of numbers so they're ordered from smallest to largest. We're actually going to look at two different ways of sorting an array. We're going to look at what's known as a bubble sort and a selection sort. So let's start off with the bubble sort. This is known as the simplest sorting algorithm. An array is traversed from the first element to the last element. In the sort, the current element is simply just compared to the next element. So we look at, for example, element in index 0 and compare it to element in index 1. If the current element is greater than the next element, it's swapped. You're just simply going to switch the location of those two values. Now, a bubble sort will always start back at the index of 0. Even if the items are sorted. So because it has to start all the way over, and I'll look at the reasons why when we actually look at the code, this is very inefficient because let's just say the smallest item is already at the end of the loop. Well, then why should you have to recheck the entire array simply to try and find the smallest value? So that's going to lead us to our second algorithm, which is the selection sort. The method sort that we're going to look at in this algorithm has one array parameter called A. An array A will be partially filled, so we can use, for example, a partially filled array. So there are additional formal parameters called things like number used, which also tells us how many array positions are used. If, let's say, we're using a full array, we can simply just set it to the size of that array. Therefore, the heading for the method sort will be public static void sort double array A int number used. So in number used, again, remember you can use that as whatever the size of the array is if you want to pass in that full array. If you only want to sort part of that array, if you're only, let's say, going up to an array that has 3 elements in it, then you would only use 3 elements. Now the method sort rearranges the elements in an array so that after the method call is completed, the elements are sorted as follows. A of 0 is less than A of 1, which is less than A of 2, which is less than ... all the way up to A is less than the number used minus 1. Bubble sort, again, is going to use something very similar. We're going to, again, go from the smallest up to the largest. Now, we talk about sorting an array. One way to design an algorithm is to rely on the definition of the problem. So what are we trying to ultimately accomplish? In this case, the problem is to sort an array from the smallest value up into the largest. That means we have to rearrange the values so that A of 0 is going to be the smallest, A of 1 is the next smallest, and so on and so forth. That kind of definition to our problem yields an outline for the selection sort algorithms. So for index equals 0, index is less than number used, index plus plus, and we're going to place the index smallest element into A of index. Now there are many different ways to realize this general approach, and there's many different types of algorithms that we could implement, some of which we are not going to talk about right now because they're beyond the scope of what we currently know with our programming skills. Now the details could be, of course, developed by using 2 arrays and copying the elements from one array to the element in a sorted order, but really, we should only need 1 array, which should be both adequate to do so and pretty economical. Therefore, if you look at the method sort, it's only going to use 1 array containing the values to be sorted. We don't have a second array that we're trying to hold values in and then pull them back out of. Now, the method sort also rearranges the values in the array by interchanging pairs of values. So let's take a little bit deeper look at how the selection sort works. So if we look at this array here at right, you can see it's starting off with a bunch of unsorted values with A of 0 starting at 8 and A of 9 ending at 12. The selection sort algorithm is going to place the smallest value in A of 0. So when we look at this, our smallest value is 3, so we're going to swap with 8, and 8 will then move to that position. The algorithm then next looks for what is our next smallest element. So it's going to look in here, okay, well 3 is down here, so it's going to look through, oh, there's 5. And guess what it's going to do? It's going to do another swap. So the value, of course, A of 0 is now the smallest. So now it's going to try to find the next smallest, move to A of 1, and so on and so forth, all the way until we get a sorted array. Now the next smallest element, if we were to keep going through that sort, is an A of 6, so the algorithm interchanges the values of A of 1 and A of 6. The algorithm then positions the third smallest element, and so on and so forth. As the sorting proceeds, the beginning array elements are set equal to the correct sorted values. This means that the sort portion of the array actually grows by adding elements one after the other from elements of the unsorted end of the array. You also notice that the algorithm does not necessarily need to do anything with the value in the last index variable A of 9, because once the other elements are positioned correctly, A of 9 has to have also the correct value, because all the other ones have already been shifted around. The correct value for A of 9 is the smallest value left to be moved, and the only value left to be moved is the value that's already in A of 9. So this goes back to our conversation on sort. The method index is smallest. It would find the index of the smallest element in the unsorted end of the array, and then it does an interchange to move this to the next smallest element down into the sorted part of the array. The method interchange is another method that's here in our sort that is going to interchange the values of index variables. For example, the following call will interchange the values of A of 0 and A of 4. Interchange 0, 4, A. A, of course, again referring back to that array. Now, ultimately, we need to look at how do we compare these two sorts. Well, the bubble sort algorithm is really good for sorting an array that is almost sorted. So if you are, let's say, 90% sorted, the bubble sort is going to do really well. However, it's not really competitive with other sorting methods for most other situations. The more complex your sorting you have to do, for example, the worse your bubble sort is going to be. A selection sort is a slight improvement over a bubble sort. It's not the best option. We'll talk about that much further down the road. But a selection sort no longer checks values that are already sorted. And if you remember, bubble sorts are always going to start back at index 0, which means they, of course, are going to have more cycles that they're going to have to go through. Remember, if you are developing for efficiency versus ease, a selection sort is always going to be a much better approach versus using a bubble sort. You want something easy? Bubble sort is your friend, though. And so here, of course, we have the two algorithms. Here's our bubble sort. And one of the reasons why a bubble sort is so easy, if you look at its implementation, all it is a nested for loop. And inside of that nested for loop, all it's going to do is going to do a check to see if the position is greater than the position plus 1. If it is, we store that into a temp variable, switch those values, and then take that temp value and put it back into the next index. So a very simple program. And of course, you can see we also have a print method here in this class, so we can actually print out the array, which will be really handy for demonstrating sorted versus unsorted. One thing I do want to point out is there's this public static and counter that is in all these codes. You don't need this counter here normally for your bubble static. Reason why it's in here is because it's going to help us show, when we run our code, how many times it's going through there. So if you're writing your own bubble sort, you don't need this counter variable. You can take that right out. Now the selection sort, of course, is a little bit more complex. You can see, again, here's our counter here, so we can help keep track of that. However, in here is our sort method, and inside we have, of course, some variables that are keeping track of things here. So here is the interchange method, which actually does some of the interchange. We also get the index of smallest, which, of course, is trying to find that smallest value for us. And you can see when you look at interchange, one of the things you'll notice is that it has a thing that is very similar to how our bubble sort does. And we are taking a double value instead of an int, so you could easily change this over to an integer or double, vice versa. But here we have a double, and here we're setting a temporary value equal to the index value, and then we're, of course, passing these in to that temporary value and storing things. So they function very similar in the sorting part, the interchange here. But the rest of the algorithm for the traversing of that array is very different. So if we go ahead and head over to our sorting demo here, we can see here's our bubble sort. So we're going to go ahead and create a bubble sort call. And so I have an integer array here that is unsorted. And what I'm going to do is I can then call that. And then I can also do a selection sort, which also has the exact same thing. And we can, of course, call that as well with the sorted and unsorted. And we're also going to print the counter just to show how many times it takes for it to go through those. Now, one thing I do want to point out, I also wanted to add this in here. This is not needed for our code purposes, but this is if you wanted to use, for example, bubble sort as method. This, of course, is showing it as a whole class. You don't need to use the bubble sort as a whole class. In fact, you can use it here just as a simple method here in your code. In fact, you could even just take these nested for loops and put it in your code and your main program to have it work. So you have some flexibility in how you do some of these things. And again, the bubble sort allows you to do that because it is very easy to implement. But let's go ahead and give things a quick run. And so we get the unsorted array of integers, and here it is sorted, and you can see it says it took 14 hops. Here's the array contents before sorting for that double, and here it is sorted, and you see it took 9 hops. Now one thing I just want to show you is if I take this integer array, and let's go ahead and set that here for this double, and see how that might change with the selection sort. So if I run that, notice it's the exact same values now, but the only difference is now how many hops did it take that selection sort? It only took it 6 hops versus the bubble sort took 14. Because again, remember the bubble sort is less efficient. It's going to, again, start over every time when it's going through there. So if you're looking for something that's very simple, the bubble sort is your friend. If you're looking for something that's going to be much more efficient, selection sort is going to be the implementation you want to use.